Welcome back, guys, to Edu Academy. So, as promised, we have covered the first six portions of the topic we were discussing last day. So, I'll cover the last two portions of this topic. Okay, so stay tuned in the video. If you have not seen our previous video, I'll attach the link in the I description. You can look into there and then you can come back and watch this video. Okay, so let's start. So we have already covered the first seven portions in the previous video. If you have not seen it, please refer to the I button and get the link of the video and watch it. So we'll do the last two portions of this video. So I've already provided you the PDF in the previous video's description box. So we'll refer to this PDF only. So the agenda of today is data compression. Okay, so let me quickly move on to the PDF page. Okay. So you have to first understand what do you mean by data compression. So understand it like this. You want to send something to your friend. Let's say you have recorded let's say any video of a wildlife sanctuary. You want to send this video to your friend. But let's say the video is too large and WhatsApp does not allow you to send it. Or maybe it takes a hell lot of time to send it to your friend. So what do you do in this scenario? You have two options. You either compress the file completely. Okay, that means whatever the file size is, if it's like 200 megabytes, bring it down to like 2 megabytes or 3 megabytes, making sure that the quality is degraded. Or the next thing you can do is you post it in a cloud server and you just give the cloud server link to the person. But our agenda is here compression. So compression means what? We actually reduce the size of the file. Okay. And how do we reduce? We reduce by encoding the information with fewer bits. That means if you have a 200 megabyte picture, you encode it to make it 2 megabytes. So the biggest problem is there is a loss of quality. If the picture was of 4K HD quality, the 2 megabytes will not be HD quality. The quality is reduced because the number of pixels that were originally in the video is reduced. So what's the definition? So if you read my note, the process of reducing the size of a file or data by encoding information, as I said you, using fewer bits than the original representation. This reduces storage requirements and transmission time. As I said you, the what is the best fact of this? You can send any file to your friend with only a smaller storage. Instead of 200 megabytes, you can send the data for just 2 megabytes. And the next thing is transmission time. It will be a lot faster to send the time from one person to another. Okay, you get it? That's it. This is what we wanted to highlight here. Okay, clear? No, I hope there's no doubt. Okay, now comes the next important one. Why should we compress data? I mean, already I've said you, but let's read it again. Reduce storage space. As I said you, it helps you to send the data in a very limited space. Faster transmission time. Lower bandwidth usage. That means less data usage. Improve performance. Okay. Now, what are the types of compression? This one you have to pay attention a bit. So there are two types of compression we have to deal here: lossless compression and lossy compression. So what do you mean by lossless compression? So lossless compression means you actually allow the original data to be reconstructed, making sure no information is lost. That means the original quality of the file is preserved. But how do we do that? There are two ways you can do it. The first one is the run length encoding. So what do you do in run length encoding? In run length encoding, you group the data in certain sequences. Let's say if you have like this, if you have five A's, triple B, and double C, instead of making it as a lossy compression, we make it lossless. So how we do? There are five A's, so we can write five A as a group. Three B's we can write as three B, and two C's instead of writing CC we write two C. So we are doing what we are clubbing it. Another way you can use is Huffman coding, that is assign shorter codes to more frequent characters. Just an example: if you have a very big character like let's say char, CHR, you can just assign it with C. So C refers to what? Char. Okay. Another thing you can use is LZW, that is it builds a dictionary of patterns, or deflate, that is combination of LZ7 and Huffman coding. You don't have to remember the last two. The first two is more important. If you remember that, you're enough to secure marks. Okay, I've given you the file format that can exist: zip file. Okay, the most important one. PNG file you can use. You can use a gzip file. Okay, If you want to read the use case I've provided, you can use it for text documents, databases, program executable source code, medical imaging, legal and financial documents. Okay. And I provided you some compression ratios also. You can read it, and yep, that's enough for getting your mark. Okay. Now the next thing. What do you mean with lossy? This is the one very compressed and the data is lost. So compression method that achieves higher compression ratios by permanently eliminating less important or imperceptible information. Original data cannot be perfectly reconstructed. That means the data is lost. Quality of data is lost. We have to make sure that we will reduce the quality of the data to make sure we transfer the data into a much higher transfer rate. How does it work? I've already provided it in read. Removes data that human perception won't significantly notice. Like the parts which are not very important. Let's say if you have six parts, like let's say four parts are important, two are not important. Lossless will try to keep all of them, but lossy will remove the less important part. Then simplifies complex data by approximation. Third point, achieves much higher compression ratios than lossless. Yeah, obviously, because you can achieve a very high compression rate in the case of lossy, but quality again is degraded. I have provided the algorithms. You don't have to go into detail for your exams, but you can just know the names. That is the JPEG compression. I have already provided you the notes here. We basically use what? We use the concept of DCT. That is what discrete cosine transform. You don't have to know the detail. Just remember it like this way. Whatever frequency of colored data you have, we make it in such a way that is visible to humans. Basically, we can adjust the quality according to our preference. Then you have MP3 like audio compression, which we say, MPEG for video compression, JPEG files, MP3, everything. So use cases what? Photographs and images for web and social media. Obviously, if you post something on Instagram, the quality of click to picture, the quality you will post on Instagram will be a lot less. Then video streaming, music streaming, and video conferencing. Okay. These parts are simple, and then I have provided you a comparison table. You can read from here all the topics which just I have told to you. Perfect reconstruction, approximate reconstruction. Then this one achieves a lower compression rate, higher compression rate. This is identical to original. This is reduced quality. So every bit of information is provided here. You can refer to here. Next, the factors affecting compression. What are the factors that affect compression? What is the data type? That means what? You have to make sure the data you have should be text. Like just an assumption, if text and numbers, alphanumeric data, then it's very difficult to reduce it. Then redundancy, more repetitive data compresses more. Obviously, file format. You have to make sure that file format is something of a known type. Compression level, okay? Because the more you compress, the lesser the quality of the picture or what the file will be. Okay, and algorithm choice. It depends on what algorithm you choose for doing that particular task. Okay, next. Different types of services in cloud implementation. Now comes the most important part. What do you mean by cloud implementation? But first, let's understand what do you mean by cloud computing. So, what do you mean by cloud computing? If I tell you in short, let's say Google Drive, what do? You take some pictures, videos, documents, whatever. It automatically gets saved in where? The Google Drive. So, let's say in the next future, let's say if you want to delete the files or videos from your mobile, and let's say you don't have a backup of it, so Google Drive keeps their backup. But it's not like it's free. Yes, Google Drive allows you for free, but only for a certain limit. After the limit is passed, you have to purchase it. And I've already provided in the definition of the same. The delivery of computing services such as storage, databases, networking software over the internet on a pay-as-you-go basis, allowing access to resources without direct active management of the user. Pay-as-you-go, because if you want to have a very high cloud space, you have to pay for it. You can't get it for free. And it will allow what? Resources. You can make the resourcing, like you can put your resources in such a way that it is visible to all the publics or only selected public. What is the characteristics? On-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Okay. Now, what are the cloud service models, like the basic model? So let's discuss the first one, that is the infrastructure as a service, that is IaaS. So what does this mean? Provides virtualized computing resources over the internet. Users rent virtual machines, storage, and networks, managing everything from the operating system upwards. So, what does it basically use for? It helps you to provide virtual machines, that is, compute instances. It also provides you storage space, networking capabilities, all the things. So, what can a user do here? Basically, for operating systems, installation, updates, everything. It can also help you to establish a middleware. Middleware means what? Like if you have a task A and a task B, middleware is what? Making sure both of the tasks are regulated properly. Okay, clear till this? This is the IaaS thing. That is what you provide virtualized computing resources over the internet, which you can pay and get use for it. Okay, next. What does the provider manage? Physical hardware, data enters, virtualization layer, network infrastructure, physical security. I provided examples like AWS, best example, Amazon AWS, EC2 panel, Google Cloud Computing, DigitalOcean, etc. Okay, use cases already told you, but you can read from here. Web hosting, obviously, if you want to deploy your new website, you can deploy it in localhost. You have to deploy it in what? In a web server. Deployment and testing environment, high performance computing, big data analysis, disaster recovery, backup. Best thing is what? You can keep a backup. So what are the advantages? Complete control over infrastructure, highly flexible and customizable, cost effective for large scale operations, and no capital expenditure. But what are the disadvantages? Disadvantage is what? You will require a very high technical expertise. If your team members are not good enough to work on it, then they will create you a big problem. The user should be responsible for security and maintenance. Make sure that whatever data you have should be secure and it should be properly maintained and more complex setup and management. Next, platform as a service. If you want a very good example for this, Microsoft Azure app. So what does uh, platform as a service do? It provides a complete development and deployment environment in the cloud. Users can build, test, and deploy applications without managing the underlying infrastructure. So if I tell you in short, it will provide you a platform where you can create your application, you can test your application, you can deploy your applications. Everything you want to do, that platform will give you the opportunity. But the thing is, it's paid. You can't go it for free. You have to pay it according to a subscription plan. So what can a user do? You can basically manage the application and business logic, application data, user access, permission, every basic thing. Example, I told you Microsoft Azure. I can move down to the PDF. Yep, it's given Google App Engine, Heroku, AWS, Elastic. Okay. Now, what are the use cases? I told you web application development. You can develop it on the cloud server, API development, mobile app backend services, and rapid prototype. If you want to build a prototype and send it to a client, it's very easy to build it in the case of a platform as a service. If you use a platform as a service, advantage was faster deployment. Whatever complexity you have is much more reduced. Scalability is there. Okay, and what integrated development tools. That means there are a lot of tools to help you make sure that when you are developing something, you have all the things to help you out in that situation. But what are the disadvantages? You have a very less control over the infrastructure, potential vendor locking. That means what? There can be problems, right? Like your data is not secured and all. Okay, limited customizable. You can't customize it. There are very limited customizable options. Other than that, there's nothing else. This is what PaaS is all about. That is platform as a service. Now, let me go down. The last one, which you all know, SaaS, probably the most interesting one for all of us. That is software as a service. Delivers fully functional software applications over the internet on a subscription basis. Users can access applications through a web browser without any installation or management. Best example, Netflix, uh, Amazon Prime, Geo Hotstar. What are these? These is a software as a service. You pay, you buy a subscription of that software. You watch your favorite shows. You want to watch you want to work on your important topics with the cost of giving them something. That something is what? That means you're paying up for that service. You don't get it for free. You have to pay, as I said. So what is the best thing about this thing? When what can a user do? You can manage your data, content, user access, permissions. Also make sure that what preferences you have and how to manage your application settings. What the provider manages. This is the most important part in the case of SaaS. They manage everything. Application, data, runtime, middleware, OS, virtualization. Probably everything SaaS manages. That's why when you log into Netflix and watch your favorite show, keep in mind your data is secure because the backend team working over there is giving the full effort because they have the highest amount of work to do. Then software updates, you have to check for regular updates, patches, security and compliance, and performance and availability. You have to also check that other players, I mean, what like whatever you are doing there whatever applications you're using, whatever you're doing. Like you want to be like you want to watch a video, you want to use it for music streaming. Are they all providing you proper performance? Are they available to you? Okay, that is what you have to check. Examples: Google Workspace, Microsoft 365, Salesforce, Dropbox, etc. Netflix, Spotify is also there. Use cases, you can look from here. Email and collaboration tools, customer relationship management. You have a very good, you can build a trust between a customer and the person who is in charge of it. Then you can do what? Office productivity, project management, and communication platforms. So overall, there are a lot of advantages. No installation is required. Automatic updates. It is accessible for literally everyone and quick to deploy. But what are the disadvantages? Again, customizable options are very less, very minimal customization options. It depends on internet connection. You don't have an internet connection, you can't use SaaS even if you pay for it. And you have to make sure that your data is stored with a third party. So you have to be comfortable with that. It's not like everything will be stored with Netflix. Data will be stored to a third party. Okay. This is just a comparison of all the three service models we discussed. You can read from here. Okay. Now let's quickly come to the next one. That is cloud deployment model. The first one is public cloud. What do you mean? That these services are available to everyone over the public internet. You can, me, everyone can use it. What are the advantages? It's cost effective, highly scalable, and no maintenance. Disadvantages: less control, chances of security breaches. Next is private control. What does this mean? It is solely held by one organization. Netflix, hold by one organization. Amazon Prime, hold by one organization. That means what? It can be hosted on premises or by a third party. The person assigned can also host it, or someone else also can host it. But the best thing about this is your data and security is much more efficient here. But what are the problems here? You need a very good person who is expert in IT, because if he's not expert in IT, then your system will collapse. Also, you have to make, also the problem is it's not very much scalable and it's very difficult to fix also. What do you mean by hybrid? Combination of both public and private. Data and application are shared between them. Advantages, you can just like think like this: flexible, cost will be also optimized and scalable. But different, but the disadvantage is very complex to manage, because if you are hybriding something, it's very difficult to manage both of them. What do you mean by community cloud? Shared infrastructure for specific community, organization with common concerns, government agency, healthcare. That means if, let's say, someone has to send an important intelligence report to a country, you just can't like email or just write like WhatsApp message and send it. No, it has to make sure that it's transferred through a secure service. That means government agencies, healthcare organization, whatever is involved, everyone should know what you are sending. So that means what costs are shared, means specific requirements. But the problem is again security. There's, you know what, everyone, everything is being monitored. So your security is in the hands of literally everyone. Okay. Benefits is what? Cost savings, obviously, scalable, available, reliable, easy to collaborate. But what are the disadvantages? I mean, basically the challenges. Challenges are what? Security problems. Yep. Even though give the data to the most secured organization, there can be a chance that your data can be lost. Internet dependency. It has to have a active and valid internet connection to make sure you can use all available features. Data location. Every time you do something in a software as a service, you have to make sure your data is on, your current data, which location. All this unethical, but that's how the company works. Okay, this is just like containing some exam tips and summary. What we have done, you can just read from here. Summary, like a quick reference, you can read from here, and that's it. We covered the last two parts. So I guess it was fine with you, right? It was a very simple part, simple logic, theoretical one. You can read this PDF, and I can guarantee you write this in your answers in your exam, you will definitely get good marks. Okay, so yep, let's keep it till this. Our next target will be to start with the next portion, that is Boolean logic. Another interesting one. So, yep, thank you. Bye. See you in the next video. So.